Next we'll see about bitwise operator. So what are bitwise operators? Bitwise operators work with an individual bits. Okay. So usually what happens is when you take an arithmetical operator plus, when you perform the arithmetical operator on an integer data, it will fetch at a stretch 2 bytes data and then perform the operation. Whereas bitwise operators will work with an individual bit, not byte by byte, it will work with an individual bit. So, and perform by bit operation. Hence it is called as bitwise operators. Now, there are 6 total bitwise operators. The first we'll see the truth table of AND, OR and NOT. Now, if you take an AND operator, okay, if any one is false or both are false, the result is going to be a false. That is 0 and 0, it's going to be 0. 0 and 1, it's going to be a 0. 1 and 0, it's going to be 0. And 1 and 1, it's going to be a 1. Same if I apply an OR. If any one is true or both are true, the result is going to be nothing but true. Whereas there's an XOR. For XOR, there's a caret. When both are same, both the inputs are same. So first one is 0, second one is 0, the result is going to be 0. The first one is 1, and the second one is 1, the result is going to be 0. If both are not same, then the result is going to be nothing but 1. Okay. So fine, we'll take an example and see how this bitwise operator works. Now, let's take here a value is equals to 0x, I'll give it A3. So this one is nothing but an hexadecimal literal constant. That means A will have a value here 10, 10, 00, 11. Okay, A is nothing but 1010 and 3 is nothing but 0011. That is a total 8 bits. Similarly, I'll take here B value is equals to again 0x. Let's have here B5. Okay, that means B is going to be nothing but here 1011. 5 is going to be here 0101. Fine. Now we'll apply an bitwise operator. First we'll take up an OR. Okay. We'll apply an OR operator. So this is good. If I give C is equals to A OR of B. So this OR is a single pipe. So it's a single pipe. If I use a double pipe, then it is a logical operator. Now this one is a single pipe. It's a bitwise operator. Then what will be the value of C? Now when I apply a bitwise operator for this both operand A and B, it will apply it for individual bits here. That is 1 or 1, it's going to be an 1. 0 or it's going to be 0 or 0, it's going to be 0. 1 or 1, it's going to be an 1. 0 or 1, it's going to be an 1. 0 or 0, it's going to be an 0. 0 or 1, it's going to be an 1. 1 or 0, it's going to be an 1. And 1 or 1, it's going to be an 1. That means if any one or both are true, the final result is true. So that means what will be the value of this C variable? In this case, it's going to be nothing but B7. I'm talking about an hexadecimal value, B7. Same way, if I apply here, C is equals to A and of B. So here, 1 and 1, it's going to be an 1. 0 and 0, it's going to be an 0. 1 and 1, it's going to be 1. 0 and 1, it's going to be an 0. 0 and 0, it's going to be 0. 0 and 1, it's going to be 0. 1 and 0, it's going to be 0. 1 and 1, it's going to be an 1. So that means here you have, now for AND what happens is both have to be true. Here in this case, 1, this is 2, and this is the third one. Okay. Sorry, this is the last bit. So that is only these 3 are 1. So the final result is going to be nothing but here. This is going to be an A and this is going to be an 1. That means the final result is going to be an A1. The same thing if I apply here XOR, that is C is equals to A XOR of B. In that case, C is equals to, as I told you, if both the input is same, then the final result is going to be the same. That means 1 XOR 1, it's going to be, if both input are same, the result is going to be 0. So here 1 XOR 1 it's going to be 0, 0 XOR 0 it's going to be 0, 1 XOR 1 it's going to be an 0, 0 XOR 1 it's going to be an 1, and 0 XOR 0 it's going to be again 0, 0 XOR 1 it's going to be an 1, 1 XOR 0 it's going to be an 1, and 0 XOR 0 it's going to be 0. So that means the final result, if you apply an XOR, it's going to be nothing but here 1 and then 6. Fine. Now there's ones complement operator. There's a ones complement operator. There is nothing but here. This one is an and this one is an XOR. Whereas next we'll see is an tilde symbol. This tilde symbol is nothing but an ones complement. It's an ones complement. Fine. Let's see what happens when you apply an ones complement. C is equals to, it's a unary operator, so you have to give a tilde symbol of A. Okay. So there is no two operands, there's only one operand here. Tilde symbol of A and then gives him. So what this ones complement does is, it will convert all ones to zeros and or convert all zeros to ones. So I am asking here ones complement of A. So that means your A value here, it is going to be 1 0 1 0 0 0 1 1. So all zeros are converted to ones and all ones are converted to 0. That means your result is of C value, it's going to be nothing but 0 1 0 1 1 1 0 0. That means here the value is going to be nothing but, this is an 5, and so this is going to be nothing but C. Fine. That means the final result is going to be 5. The next one we have is an right shift. Right shift, and second one is an left shift. 2 less than symbol, we call it as a left shift bitwise operator. Fine, we'll apply here right shift. C is equals to A right shift of 3 bits. Let's take here A value as 1 0 1 0 1 1 0 1, and if I apply a right shift of 3 bits, so these 3 bits will be truncated and the remaining 3 bits will be shifted 3 position right. 3 position right means what happens? Here you'll have 1 0 1 0 1, and it will add 3 zeros because you have shifted here. These 3 bits have been truncated. 3 zeros will be added at the end. So you have here 1 2 3 4 5 6 7 8. So that means the value is going to be here as an 1. This is nothing but an 5. If I've shifted it 3 bits, okay, so 3 bits will be truncated and add 3 zeros at the left. Similarly, if I go for left shift operator, so by giving a C is equals to A left shift of 2 bits, if I give, so here A value, assume that it is 1 0 1 0 1 1 0 1. So 2 bits have to be shifted left. That means these 2 bits will get truncated and the remaining 6 bits will be shifted to position left. That means you'll have here 1 0 1 1 0 1, and will add 2 zeros at the right side. That means you have here a value is nothing but B5. So these are the 6 bitwise operators. That is, you have an OR, this is an AND, XOR, ones complement, right shift and left shift. All these operators are working with an individual bits, hence we call this as an bitwise